In this video, I'll focus on how to find the greatest coefficient or the largest coefficient of a binomial expansion with negative powers. So let's say you have a binomial expansion with negative power, such as 6 minus 4x raised to power minus 3. One of the first things to note whenever you have a binomial expansion with negative power is that it must conform to the general equation, which is 1 minus b or 1 plus b, okay, raised to power minus n raised to power minus n. So for this question, it looks like this. In this video, I will use this throughout the video and you really understand, so I will advise you don't skip around this video. So anytime we have this binomial, its expansion is generally 1 plus nb plus dot 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 as it continues. This is generally equal to summation. you know I can still rewrite this as this 1 over 1 minus b raised to power n. Okay, so and it is generally given by this x equation, which is as r starts from 0 to the point where r is infinity. At this first term where this I have 1, r is equal to 0. At this point r equals to 1. So r starts from 0 and then it continues like that to infinity. So this represents the summation, that is the addition of each of the terms. Okay, then I will have n plus r minus 1 combination r dot b raised to power r. So this is the generally accepted equation whenever we have a binomial expansion with negative power. So one of the things I will first of all do if I want to expand this, or if I want to find the greatest coefficient, is to make sure that this 6 minus 4x looks like 1 minus b. And how am I going to do that? I will factorize 6 from this binomial. So if I bring out 6 from the binomial by method of factorization, I will have 1 minus 4x over 6. Okay, so I'll still put the brackets and then the power, which is minus 3. Okay, now if I split what I have inside the bigger bracket, I will have something of this nature: 6 raised to power minus 3, then open another one, 1 minus 4x over 6, which is the same thing as 2x over 3 raised to power minus 3. Okay, according to law of indices, anytime I have two things inside a bracket and they have just one power, they can share the power. That's a raised to power m, b raised to power m. So what I just did now, it satisfied this law of indices. Okay, so one of the things that I will do now is to find the expansion of this. Then after finding the expansion of this, then I will locate the greatest coefficient. But because it's an infinite series, if you expand this, it is infinite. To locate, you can't finish the expansion, and as a result, to find the greatest coefficient, to you will not be able to find it. But there is a way you can manipulate it such that you will not need to expand the binomial before you know the greatest coefficient, and that's what we want to do now. Okay, so 6 raised to power minus 3, and then open bracket 1 minus 2x over 3 raised to power minus 3. If I expand it, I will have summation as r starts from 0. Okay, that is, I will start the expansion by adding some terms, and then r will begin from point where it is 0, and then I will have n combination n plus r minus 1 combination. So just from this point, I'm using this now. Okay, so my n is equal to 3. If you compare this with this binomial, you would see that my n, okay, before then let me just have 1 minus 2x over 3 raised to power minus 3, okay, which is the same thing as the infinity. Then r starts from 0, okay, 6 raised to power minus 3. Then I will have something of this nature, n plus r. My n in this question is 3, and then my r remains r, so I have minus 1. So 3 plus r minus 1, that's supposed to be r plus 2 combination r dot b. In this case, my b is 2x over 3 raised to power r. So if you compare it, b and this is b, okay, this is 1, and of course this is 1, okay. So 6 raised to power minus 3 is just a coefficient, okay. So that is actually equal to infinity sum and then 0, 6 raised to power minus 3 r plus 2 combination 2, and then 2 over 3 raised to power r, then x raised to power r. Notice that I splitted this, okay. I splitted 2x over 3 and then x raised to power r, which is still the same, just according to this law too. Now notice that I did something, which is I changed r plus 2 combination r, I changed it to r plus 2 combination 2. Is just a form of simplification, and the reason is because n combination r is equal to n combination n minus r, okay. So in this case I have r plus 2 serving as my n, and then r is r, then I have r plus 2 again, and then n minus r would mean r plus 2, r plus 2 minus r, okay, which is the same thing as 2. So that's why I have 2 right here, n minus r. So my n is r plus 2 for this question. You don't need all of this, but it is good to do this for better simplification, okay. But just understand that n combination r is equal to n combination n minus 1. So in this case, my n here is r plus 2 here, and r remains r. So if n is here now, and then this is still my n, which is r plus 2, so this place is supposed to be n minus r. That's r plus 2 minus r, which is equal to 2. So that's why I have 2 right here, which is this, okay. Now let me get rid of this space. Now, so what do we do after this? It should be noted that anytime we expand a binomial, okay, anytime we expand a binomial, let's say 1 minus b raised to power minus n, it will be equal to this expression, okay. But I can just write it as something of this nature: infinity, then r equal to 0, then ar raised to, then x raised to power r, okay. If you notice, you will see that b is a function of x, and then it looks like this too, okay, where ar is the coefficient and then x raised to power r is the variable, okay. So for my own question now, my coefficient a sub r, I'm just using it to represent the coefficient, is equal to 6 raised to power minus 3, then r plus 2 combination 2, then 2 over 3 raised to power r is my coefficient, okay. But note that if I expand, I will have many coefficients that I will be summing together. So if I split this now, I will have x raised to power r. I can also have another one. The next term will be ar plus 1, x raised to power r plus 1. The next one will be r plus 2. The one before this is ar minus 1, x is to power r minus 1. So if I assume, and these are the coefficients, these are the coefficients, these are the coefficients, and of course each of the coefficients is equal to this. Okay, so if I assume that ar is the coefficient, it will mean that ar is greater than, it is greater than or equal to ar plus 1, or it is greater than or equal to ar minus 1. So since I already assumed that ar is the greatest coefficient, that means this assumption is what, if I follow this assumption, it will mean that ar is assumed to be the greatest coefficient. Okay, so if this is my ar, then my ar plus 1 will be equal to 6 is to power minus 3. Anywhere I see r, I will change it to r plus 1. So r plus 1 plus 2, that will be r plus 3 combination 2. Then I will have 2 over 3 r plus 1. Anywhere I see r, I change it to r plus 2. So by assumption, I assume that ar is the greatest coefficient, and ar is greater or equal to ar plus 1. So it will mean that all this is greater than or equal to this. So if I write that out mathematically, let me get rid of, okay, if I write that out, I will have 6 is to power minus 3 r plus 2 combination 2, 2 over 3 is to power r, it has to be greater than or equal to 6 is to power minus 3 r plus 3 combination 2, 2 over 3. Notice that r plus 1, notice this, according to law of indices, that anytime a raised to power r plus 1 is the same thing as a raised to power r dot a, because the power of this a is 1, and whenever you multiply two things with the same base, their powers are added. Okay, so I will just split this to 2 over 3, which is raised to power r, and then dot 2 over 3, according to this law of indices that I have right here. Okay, so I can now divide. I can say that 2 over 3 raised to power r cancel out with 2 over 3 raised to power r, 6 is to power minus 3 cancel out with 6 raised to power minus 3. So I will have something of this nature: r plus 2 combination 2 is greater than or equal to r plus 3 combination 2, and then I have this 2 over 3. So so let me just demarcate this. So I have r plus 2 combination 2, and then greater than or equal to that. Notice this formula. Anytime you have n combination r, it is actually equal to n factorial over n minus r factorial, then r factorial. Okay, so I will use that same formula now. I have r plus 2 factorial. R plus 2 factorial, that will be r plus 2. No, I have r plus 2 combination 2, so it will become r plus 2 factorial over r plus 2 minus 2, okay, factorial, and then 2 factorial from n combination r, which is equal to n factorial over n minus r factorial, then r factorial. Okay, so you know, from this place, r plus 2 is my own n, so it becomes r plus 2 factorial at the numerator, and then this part, n minus r, my r is 2, so my n is r plus 2. So I believe you understand that. Now let me write out that of r plus 3. R plus 3 will become r plus 3 factorial upon r plus 3 minus 2 factorial, then 2 factorial. Okay, so that's what it will become. Now let me get rid of this space. So from this point, r plus 2 combination 2, I have gotten it as r plus 2 factorial, upon r plus 2 minus 2, which is the same thing as r factorial, and then 2 factorial. So it has to be greater than or equal to r plus 3 factorial. Notice that I can still simplify this. Okay, I will try to simplify this r plus 3 factorial, because it must be noted that anytime you have r factorial means, okay, let me use b for instance. If you have b factorial means b multiplied by b minus 1 multiplied by b minus 2. It continues like that, b minus 3, b minus 4. So I can stop by putting a factorial. Okay, so if I have r plus 3 factorial, because I would like it to be to cancel out with r plus 2, I would like to reduce it so that it becomes r plus 3, and then the next one will be r plus 3 minus 1, which is r plus 2, and then I will put it with factorial. Okay, so r plus 3 minus 2 is the same thing as r plus 1. So there's a way I can write r plus 1 that it will end up in r factorial. So that will be r plus 1, r plus 1. The next one will be r plus 1 minus 1, which is r. Then I'll end it with factorial, and then I can have 2 factorial. So if I put that here, I will have r plus 3, and then I will have r plus 2 factorial upon r plus 1. Okay, then r factorial 2 factorial. So some can cancel out, 2 factorial will cancel out, r factorial will cancel. So that was the main reason why we needed to split this, so that it will be able to cancel out and we will not have factorials again. So don't forget that there is an outstanding 2 over 3 right here. Okay, so I will have 1 here, everything has been divided. Then I will have r plus 3, no more factorial, and then I will have r plus 1, no more factorial, and then I will have 2 over 3. Okay, notice that I can cross multiply so that it will be equal to 3 into r plus 1, then greater than or equal to 2 into r plus 3, which is the same thing as 3r plus 1. No, 3r plus 3 greater than or equal to 2r plus 6, and that's of course 3r minus 2r, which is greater than or equal to 6 minus 3. That's r is greater than or equal to 3. Okay, so if r is greater than or equal to 3, it means that the maximum coefficient is found. I can, the least point, what this actually means, it is from the point where I assume that ar is greater than or equal to ar plus 1. Okay, but if ar is greater than ar plus 1, it will mean, it is what it actually means for ar to be the greatest coefficient is because is that ar is greater than ar plus 1. So the reason why we normally use equal to is because, for instance, now if I had used only greater than, I will end up having r greater than 3, which will mean that r is r are numbers such as 4, 5, 6, and the likes, but the smallest value of r is still 3. Okay, the smallest value of r is still 3. So that's why we normally consider that. So if r is greater than or equal to 3, the least value of r is 3. Okay, so the greatest coefficient is found at the point where r is equal to 3. By assumption, we said that ar is the greatest coefficient. Okay, so if I substitute r, which is equal to 3, into ar, I will have 6 raised to power minus 3. R is now 3. 3 plus 2, that's 5, combination 2 dot 2 over 3 raised to power r, and r is given as 3. So 6 raised to power minus 3 times 5 combination 2 multiplied by 2 over 3 raised to power 3. If you press that on your calculator, that should be equal to 10 over 729. So this is the greatest coefficient for that particular binomial with negative power. Find the greatest coefficient, or what is the largest coefficient of 4 plus 3x raised to power minus 5. Okay, remember that anytime we have negative powers binomial, we must always use this 1 minus b raised to power minus n, and of course it is equal to a particular kind of series which we can compress to summation, as r starts from 0 and then it ends in infinity, n plus r minus 1 combination r dot b raised to power r. It's very simple to understand. Okay, so one of the things I need to do now is to make sure that the given question looks like 1 minus b. So how do we normally do that? We factorize 4, this particular one, without x. We factorize it out of the binomial so that we have 1 then plus 3x over 4 raised to power, the power still remains raised to power minus 5, and according to law of indices they will both share the powers. So that's 1 plus 3x upon 4, they share the powers as well, raised to power minus 5. So this is a binomial, this is binomial, and then this is just serving as a coefficient. All right, so one of the things that I need to do now is to make sure that this binomial actually looks like, it looks properly like 1 minus b. So what I would just have to do, because I want to find its greatest coefficient, and I told you that in this video which is about greatest coefficient, I will be using this formula alone, and that will really be helpful. Okay, so it has to be equal to 4 raised to power minus 5, 1 minus, it is not burdensome. Okay, it's just something you can still understand. It's just by introducing the negative sign. So you know, minus times minus is still the same thing as positive, so nothing has changed. It's just that I am compelled to use negative here. Okay, simply because I want to follow this 1 minus b. So my b is minus 3x over 4. All right, so if I'll be using this formula now, then I should have something of this nature: 4 raised to power minus 5 into 1 minus 3x over 4, okay, raised to power negative 5. Then that should be equal to this 4 raised to power minus 5 summation as r, I mean summation as r starts from 0 to the point where r becomes infinity, and then we have n plus r minus 1. In this question my n is 5. Okay, if you check it very well, this is n, this is 5. So my n is 5, that's 5 plus r minus 1, that's of course 4 plus r combination r. Okay, and then b raised to power, and then my b is minus 3x upon 4, then raised to power r. Okay, it is still the same. Don't forget I can write 4 raised to power minus 5 inside this summation too. It makes no difference. Okay, so let me just try to simplify that. Okay, equal to 0, 4 raised to power minus 5. Don't forget I told you 4 plus r combination r is equal to 4 plus r combination 4, simply because n combination r is equal to n combination r minus 1. No, n combination n minus r, isn't it? So that when you had n r plus n minus r, it has to give you n. Okay, the same way r plus 4 will give you 4 plus r. So that's just the difference. Now, okay, let me quickly get rid of this so that it will not be rough. All right, so if I rewrite this now, I will have 4 plus r combination 4. Okay, then I can split this into minus 3 over 4. No, I can split it into 3 over 4 raised to power r, then minus 1 raised to power r, and then x raised to power r. So it is very very good to split the minus sign from this, from 3 over 4. So I can just have something of this nature. Okay, I'm just trying to make it simpler in look. It's not as if the step is that much. Okay, the step is not that much. I'm just trying to do a lot of things to simplify it. Okay, so I will have 4 raised to power minus 5 is 1 over 1024. Okay, so I have my 4 plus r combination 4, and then I have 3 over 4 raised to power r, and then this is the variable. So all of these forms the coefficients. Okay, it is just like having something of this nature: infinity, then r equal to 0, a sub r, and then x raised to power r. So in this question, my ar is equal to minus 1 raised to power r upon 1024. Then I have my combination 4 plus r combination 4, and of course 3 over 4 raised to power r. So this is my r. Alright, normally I'm supposed to say ar is greater than or equal to ar plus 1, and then I continue just like I did in the last question. But for this kind of problem where I have positive right here and then I have negative binomial, it is something of this nature. It is something of this nature. Let me write it out: 1 plus b raised to power minus n. You will notice that if I try to expand something, a binomial that looks like this, I will have 1 minus nb, then plus minus n into minus n minus 1, then b squared over 2 factorial. If we check this very well, minus n minus 1 is negative, and then this negative, the sign that we have right here will be positive. The sign I have here is negative, the sign I have here is positive. So one of the things you must notice is that the signs alternate for a binomial expansion with negative powers having positive right here. They will have coefficients that will be alternating in signs. Okay, they will have coefficients that will be alternating in signs. So one of the things I need to do to find the greatest coefficient, I need to track out only the positive coefficients. I need to track out only the positive coefficients. So to find the greatest coefficient, I only need the positive coefficient, because of course if we have a binomial where the coefficient alternates, plus minus, the greatest coefficient will be the ones, it should be among the ones with the positive sign. Okay, so one of the ways to track out only the positive coefficient is to consider r as 2n for positive coefficient, and then r is equal to 2n plus 1 for negative coefficient. You understand? So these 2n and 2n plus 1s are just general formula to express even numbers, and then this one is to express odd numbers. So that's just it. So what I need to do now is to say that my ar will now become r will now become 2n, since I'm only considering only the even, that is the positive coefficient. So this is for positive coefficient, this is for negative coefficient. So if I only want to track out the positive coefficient, my r should become 2n. Okay, so I will have minus 1 raised to power 2n. 2n is just the general formula for even numbers. Okay, so and then I will have 4 plus r combination. Okay, r is now 2n, so instead of having r, I should have 2n. Okay, that's 4 plus 2n, then combination. Okay, combination 4, then I'll have 3 over 4 raised to power r, which is now 2n. Okay, so but notice that minus 1 raised to power 2n, 2n is an even number. Okay, so it has to, n can be any number. Minus 1 raised to power 2n is 1. Okay, but minus 1 raised to power 2n plus 1 is minus 1. So we don't need to include that in our solution again. So a2n is now 1 over 1024, then 4 plus 2n combination 4, and of course 3 over 4 raised to power 2n. So this particular should be greater than a2n plus 1. Okay, notice that this a2n plus 1, a2n plus 1, it is not the same thing as a, it is not the same thing as a2n plus 1. So there should be a bracket anywhere you see n, only n is changing to n plus 1, so there should be a bracket. Okay, so and of course a2n would mean that anywhere I see 2n, I need to replace it with 2n plus 1. Notice that I did not put greater than or equal to sign right here, simply because it is not that close to it. A2n is not that close to a2n plus 1. A2n plus 1, that's a2n plus 2, isn't it? If I expand the bracket 2 times n, 2n, 2 times 1, 2, it is very, very great. It is strictly greater than it. You understand? It is like the next two term. After the next term, the immediate term should be odd, so the next one should be the even. Okay, so I just need to do the substitution now. Okay, so it has to be greater than 1 over 1024, then 4 plus 2 into n plus 1, then combination 4, and of course 3 over 4 raised to power 2 into n plus 1, isn't it? Now I can still have, let me just cancel out this coefficient because it can be cancelled out. Okay, so that I will still have my simpler version, 4 plus 2n combination 4, and that's 3 over 4 raised to power 2n greater than 4. 4 plus what I want to have now, which is supposed to be 4 plus 2 into n plus 1, is the same thing as 4 plus 2n plus 2, which of course is 6 plus 2n, isn't it? And again, this point, that point where I have 2 into n plus 1, 2 into n plus 1 is the same thing as 2n point 2, isn't it? And of course, according to law of indices, if I have a raised to power 2n plus 2, it is the same thing as a raised to power 2n dot a raised to power 2, because according to law of indices, if I have the same base, I need to add the powers. So that's what I will be doing. I will split the power. I'll split the power so that I will have something of this nature. I'll have something of this nature. Okay, I will have 6 plus 2n combination 4, then 3 over 4, then I will have 3 over 4 raised to power 2n plus 1, of which I can split so that it will become 2n dot 3 over 4 raised to power 1, raised to power 2. Okay, just like this rule that I have just showed you. Alright, so with that influence I can cancel out this. Okay, because it is common to both sides, which is the same thing as 4 plus 2n combination 4, and then greater than 6 plus 2n combination 4. and of course this is supposed to be 9 over 16. Okay, so I will just have to do the combination of that and then get the n now, and that will be very very interesting. So let me get rid of this space. Okay, so 4 plus 2n is the same thing as 4 plus 2n factorial upon, don't forget I told you n combination r, so the same formula is what I'm using. So 4 plus 2n is my own n, so that's supposed to be n minus that now, so that's supposed to be 4 plus 2n minus 4, which of course should be 2n factorial, then r factorial, that's 4 factorial. It's supposed to be greater than, it's strictly greater than, okay, it's supposed to be greater than 6 plus 2n factorial upon 6 plus 2n minus 4. That's supposed to be 2 plus 2n factorial, then 4 factorial. Don't forget 4 factorial can actually cancel out 4 factorial, and of course this 6 plus 2n factorial, don't let me omit 9 over 16, very very important. 6 plus 2n factorial will become 6 plus 2n, then 5 plus 2n, and of course 4 plus 2n factorial, okay, upon 2 plus 2n factorial, then I'll have 2 plus 2n, then 1 plus 2n, and of course 2n factorial. Okay, so I already explained it is simply because anytime you have b factorial, it is the same thing as b into b minus 1. There must be a subtraction of 1, b minus 2, then I will always have to end it with the factorial sign. So this side remains the same because it is smaller to the other side. So I can always find everything in this side inside the other side. So 2n factorial cancels out 2n, and then this also cancels out with this. So on that side 1 is greater than, don't omit 9 over 16, 1 is greater than 6 plus 2n into 5 plus 2n, then 9 upon 2 plus 2n, okay, 1 plus 2n 16. So if I cross multiply, I will have something of this nature: 2 plus 2n, then I will have 16 right here, then 1 plus 2n greater than 6 plus 2n into 5 plus 2n, okay, then I should have 9 right here. So if I expand these brackets, okay, I should have something of this nature. I should have 16 into 4n squared plus 6n plus 2. So you can always practice that. Greater than 9 into 4n squared as well plus 22n plus 30. Okay, and of course if I expand throughout, 6 times 4, that's supposed to be 64n squared, okay, plus 96n, and of course plus 32, which is greater than the next one. 9 times 4, that's supposed to be 36n squared, then plus 198n plus 270. Okay, so if I take 36n to the other side and then I collect some like terms, I should have 28n squared minus 102n minus 238, which is greater than 0. So if I reduce it by dividing through by 2, I'll have something of this nature: 14n squared minus 51n minus 119 greater than 0. Okay, now by solving that particular quadratic, let me quickly get rid of this space. By solving that particular quadratic, I should have something of this nature: n is greater than plus 5. I'm supposed to have plus or minus 5, but we don't need the negative aspect because n cannot be negative. We only want the positive. So I'm supposed to have 51 squared, that's b squared plus 4ac. Then 4 is supposed to be 14. Then c is supposed to be 119. So I'm using the quadratic formula upon 2a, and of course the a is 14. So if you do this correctly, if you do this arithmetic correctly, you should have an approximate value of 5.3. now, which means that n is greater than 5.3. Okay, if n is greater than 5.3, being a positive value, it will mean that n is equal to 6, n is equal to 7, n is equal to 8. So but what we normally use is to use the least positive value of n. The least positive value of n will give us the greatest coefficient of the binomial. If I consider the least, that means n is 6, it will mean that the greatest coefficient, which is a2n, will occur at a2 times 6, which is a12. That means the greatest coefficient a12 is equal to 1 over 1024. Then that's supposed to be 16 combination 4. Okay, 16 combination 4 into 3 over 4. Then I should have 12 right here, that's 2n. Okay, so if you do this correctly on your calculator, you will have something of this nature. You should have 241805655 over 4294967 So you can just press 16 combination 4 on your calculator, multiply with 3 raised to power 12 over 4 raised to power 4, 12, then multiply by 1 over 1024. So you'll be fine. You should get that if you do it correctly. So don't forget we had 2n plus 4. That's how we got to the 16 plus 4. Now n is 2n is now 12. So 12 plus 4, that's of course 16. So that's how we have 16 at that point. So that's it. So this is the greatest coefficient of that particular binomial. Okay, now let's say you want to find the greatest coefficient of 3 plus 4x raised to power minus 5. These are not that kind of thing that you need to note now. I have already advised that you don't skip around this video. Of course, you know that one of the things that we must first of all do is to to factorize 3 out so that we'll have something of this nature. Okay, raised to power minus 5, raised to power minus 5. Okay, just as we have been doing. Now, okay, I will have something of this nature, 3 raised to power minus 5 into my binomial as r tends to 0, n plus r minus 1, that's 5 plus r minus 1, that's of course 4 plus r combination r, and sometimes I used to convert it to 4. So then I will have b, and of course the b would become minus 4, which is the same thing as 4 upon 3, then x raised to power r, then I should have minus 1 raised to power r, and of course I should have x raised to power r. Okay, just like the last example. In the last example, I did it step by step. You know, I just want you to know that it's as simple as this. Okay, so okay, what I'm just trying to do now is to try to explain so that you can remember. Okay, so you remember I needed to do this so that it will conform to 1 minus b raised to power minus n. Okay, so this is what I will eventually have. This might be, these are the b's. I splitted the b's already. Now, one of the things I want you to note is that anytime we have a binomial of something of this nature, actually I'm supposed to continue now by just saying that my AR is equal to 3 raised to power minus 5 minus 1 raised to power r, and then 4 over 3 raised to power r. Okay, 4 over 3 raised to power r, and then 4 plus r combination 4. I'm supposed to continue now, and then I will know, and then I will say r is equal to 2n. R equals to 2n because it has to do with positive and negative, so that I'll be able to track out only the even, the positive coefficient. Okay, but then one of the things that you must also notice that it is not all binomial that can yield that has greatest or minimum coefficient. Some binomial do not have. An example of a binomial that does not have is this kind of binomial, simply because as r increases from 0 to infinity, this combination series, this combination, okay, this combinatorial sign, this combination will always increase. As r increases, the combination will also increase. Okay, always. And that's why if you say r is 0, then I will have 4 combination 4. If you say r is 1, then I should have 5 combination 4. If you say r is 2, then I should have 6 combination 4. 4 combination 4 is 1. 5 combination 4, that should be 5. 6 combination 4, that should be something of, okay, oh, 6 combination 4, that's supposed to be 15. That's supposed to be 15. And then if I do it correctly, if I have 7 combination 4, that's supposed to be 35. So this is the point where r is 0, r is 1. So as r value increases, combination increases. Now, what will now determine if we can have this, because this 2 is always constant. Now, what will now determine if we have greatest coefficient or not is whether our b, which is 4 over 3, will it also increase as r increase or decrease as r increase. If our b also increase as r increases, then we cannot have greatest coefficient. It must decrease. Okay, and that's why it means that b, the absolute value of b should be less than 1. Okay, it has to be less than 1 for us to be able to have greatest coefficient. So for this now, that's 4 over 3, and that's like 1 point something. So if I increase the r value by 0, 1, 2, the value will begin to increase. But let's say we had 3 over 4. 3 over 4 is less than 1. If I increase the r value, like 3 over 4 raised to power 0 is 1, then 3 over 4 raised to power 1, it will decrease. That's 3 over 4, which is 0 point something. If I increase it to 2, as r increases, 3 over 4 will be decreasing. You understand? 3 over 4 raised to power 2 will decrease. So let me just show you that 4 over 3 raised to power 0 is 1. 4 over 3 raised to power 1, this is supposed to yield 1.33. And of course, 4 over 3 all squared, that's supposed to be 16 divided by 9, that's supposed to be 1.78. So the value also increases. So if I also have 4 over 3 raised to power 3, that's supposed to be 2.37. So as r value increase, this will also increase. So I can never have greatest coefficient. If you check the last problem, what we had in the last question was, that's supposed to be 4 plus 3x, That's supposed to be 4 plus 3x raised to power minus 5. Okay, minus 5. And by factorization of b, which is 3 over 4, is less than 1, so we had a greatest coefficient. That's just it. So this kind of question, no maximum, no minimum. So that's it. Now, let me just explain one of the things that you must know about this, about all that I have right here, or all that I have right here, is that as R value increases, the combination increase, then 4 over 3 will also increase, which would mean that we will not have greatest coefficient. And then minus 1 raised to power 5, minus 1 raised to power r, as r value increases, the minus 1 begin to alternate, so we'll have something of this nature: plus, minus, plus, minus. Okay, now but as 4 over 3 also increase, it will bring about, since 4 over 3 has an absolute value that is greater than 1, or that is greater than 1, this is the kind of example that we'll have something of this nature: 1 minus 2, then plus 3, then minus 4. 1 is supposed to be here, so I will have minus plus 5. These are the kind of coefficients that we'll have. This kind of coefficient will never have, we will not be able to arrive at the greatest coefficient because it continues to infinity. Okay, so you just need to know that the absolute value of b should be less than 1 for us to have greatest coefficients. That's it. Thanks for watching this video. Oh, I would like to solve one problem again. So this is the last example. Let's say you want to find the binomial of 1 plus x over 2 raised to power minus 2. It is already in that form of 1 plus b, but we always want it to be in 1 minus, so I will say 1 minus x over 2, okay, raised to power minus 2. We don't need to factorize anything out, so it looks very, very beautiful. So I just have my infinity r equal to 0, then n plus r minus, n plus r minus 1. That's supposed to, and my n in this case is 2. That's supposed to be 2 plus r minus 1, which is 1 plus r combination r, isn't it? Combination r dot, what do I used to have again? Dot b, that's supposed to be minus x upon 2 raised to power r. And of course, it's the same thing as r equal to 0, 1 plus r combination 1, and then x over 2 raised to power r, and of course minus 1 raised to power r. So, and of course, anytime we have plus right here, we know that the sign will be alternating, and we will only need, in fact, it is because of this minus r raised to power r, minus 1 raised to power r, which is as a result of this positive sign. That's why we will always have to fish out the positive coefficient, because as r increases, this minus 1 will be alternating, so that we'll have plus, minus, or minus, plus, plus, minus, alternating signs. So for us to have the greatest coefficient, as I explained earlier, we need to track out only the even powers, only when r will become 2n, which is a sign of the points, the terms where we will have positive coefficient. So to have only positive coefficient, to consider only the positive coefficient, our r needs to become 2n. To consider only the negative coefficient, our r needs to become 2n plus 1. So I will have infinity r equal to 0. So 1 plus r combination 1. No, my r is now 2n. So instead of having r, I will have 1 plus 2n combination 1. Then I will have x upon 2, okay, raised to power r, and of course r is 2n. Then I will have minus 1 raised to power 2n. Notice that minus 1 raised to power 2n is equal to 1, because 2n represents even number. So minus 1 raised to power any of the even number will be equal to 1. So I do not need to have this again. So I will have something of this nature. Infinity r equal to 0. Then I will have 1 plus 2n combination 1 upon 2 raised to power 2n, then x raised to power 2n. Okay, now notice that this is my coefficient, and it would mean that a2n should be greater than a2n plus 1 in brackets. Okay, so, and of course it's the same thing as a2n plus 2. So I will have something of this nature: 1 plus 2n combination 1 over 2 into 2n should be greater than a2n plus 1. So anywhere I see n, I change it to 2n plus 1. Okay, I will have something of this nature: 1 to n greater than 1 plus 2n plus 2, which is the same thing as 3 plus 2n combination 1, then 1 over 2 2n, then 1 over 2 raised to power 2. So simply because this will actually give us 2n plus 2. So this will cancel out with this. As a result, I will have 1 plus 2n combination 1 greater than 3 plus 2n combination 1, and of course I will have 1 over 4, which is equal to 1 plus 2n factorial upon 1 plus 2n minus 1, which is 2n factorial, and of course I'll have 1 factorial, and it has to be greater than 3 plus 2n. I'm supposed to have factorial, but okay, let me just do it straight away since I already explained. So I should have 2 plus 2n, then the next one should be 1 plus 2n, then factorial, okay, upon 3 plus 2n minus 1, that's 2 plus 2n factorial, which is the same thing as 1 plus 2n factorial. Okay, and again the next one will be 2n factorial. So I have 1 over 16 right here, 1 over 4. So 2n will cancel out with 2n. 1 factorial is 1, so 1 plus 2n factorial will cancel out with this. So if I cross multiply, I should have 4 into 2 plus 2n, then 1 plus 2n, which is strictly greater than 3 plus 2n. Okay, and then I have 2 plus 2n. So if you open that bracket, you should have something of this nature: 4 into 4n squared plus 6n plus 2 greater than 4n squared plus 10n plus 6. So if you expand this and then you collect like terms, you should have this quadratic: 12n squared plus 14n plus 2 greater than 0. So by solving that quadratic, or I can simply factorize it into n plus 1, 6n plus 1 greater than 0. You can check my videos where I talk about inequality, quadratic inequalities. The video will really help you. Okay, so if you solve this quadratic inequality very well, you should have n greater than minus 1 upon 6, or n less than minus 1. Okay, so if you do that correctly, we do not need n less than minus 1, because it consists of only negative numbers. Okay, it consists of only negative numbers, and our n cannot be negative. So if n is greater than minus 6, if n is greater than minus 1 over 6, which is a negative number, the smallest value of n that is positive is n equal to 0. Do you understand now? So the greatest coefficient is at the point where n is equal to 0. So our a2n, which is assumed to be the greatest coefficient, will occur. So our a2n, since n is now 0, 2 times n, that's 0. So a naught is the greatest coefficient. So anywhere I see 2n, I change it to 0. So I have one combination 1 over 2 raised to power 0 is the greatest coefficient. So, and that's of course equal to 1. Okay, so that's the way it is. So the greatest coefficient in this binomial is equal to 1. If you want me to explain this quadratic, let me just quickly do that. But you can also check my video where I already talked about how to find the quadratic, how to solve for quadratic inequality. So what you will just need to do, you can find the zeros of this quadratic, and the zeros of that particular quadratic, it should be minus 1, that is n plus 1 equal to 0, and then the other one should be minus 1 over 6, minus 1 over 6. So we have three regions, this region, this region, and this region. This region is x greater than minus 1 over 6. This region is x less than minus 1 over 6, and this is greater than minus 1, and this is x less than minus 1. So if I test a number in this region, maybe 8, if I put 8 into this, that's 8 plus 1, positive number. 6 times 8 plus 1, a positive number. So positive times positive is greater than 0. So anytime we have greater than 0, they want us to arrive at a positive number. So if this region can give us, this region will also give us the answer. You can test it. You can pick up minus 7. Minus 7 plus 1 is a negative number. 6 times minus 7 is negative, plus 1 is negative. So negative times negative is what? Greater than 0. So that's why the answer is n greater than minus 1 over 6 and n less than minus 1. But we omitted this because n less than minus 1 consists of numbers that are negative, and our n cannot be negative. But n greater than minus 1 over 6 still has positive numbers, and the least positive number is 0. So that makes our a2n to become a2 into 0, which is the same thing as a naught. So anywhere I see n, I change it to 0. So 1 is the greatest coefficient. I hope you love this video. If you like it, share it with your friends. Click the like button, subscribe to this channel, and let your friends benefit. Leave a comment to encourage other viewers. Bye for now.